data were collected before and after TSST, and participants were randomized to receive placebo for propranolol, a beta adrenergic antagonist, in a double-blind fashion. The objective of the present study was to explore a mediational role for stress-induced changes in heart rate as a proxy for beta adrenergic stimulation and effects of stress exposure via the TSST on white blood cell counts. So heart rate would be considered as an intervening variable between drug taken following stress as a predictor and white blood cell count changes outcome. So what the packages do, Lavon and Simplot packages are known to conduct mediation modeling and visual representation of path analysis, which were both needed in this study. So methodology. As seen in this diagram, 95 study participants were assigned to take either placebo or propranolol 60 minutes before the TSST exposure, and blood samples and heart rate measures were collected before, during, and after, like I stated, and differences in white blood cell count and heart rate were calculated and then used in the Lavon structural equation model. So here you can see better the equations that I used in R with this package. So heart rate being the potential mediator, M regressing on the drug taken, which would be in this case the X variable, and white blood cell count changes, the Y variable, regressing on heart rate changes, M, and drug taken. So indirect and direct, as well as total effects of paths, were examined through equations manipulating model A, B, and C paths. So you can see a bit more of that here. Moving on, the results that I got were very helpful. So the model was processed and summarized, then plotted using Simplot and tidyr packages. Multiple indexes presented in the summary were used within reasonable measure to indicate functionality and model accuracy. And these index tests met preferred ranges. So as you can see here, the chi-squared test, the p-value was less than 0.05. The comparative fit index was greater than 0.9, and the Tucker-Lewis index was greater than 0.95, which meant the model was functioning well, and we could then examine other values calculated in mediation. So these are those other things that were estimated by the model that I just talked about. So this figure shows summarized results of structural modeling equation with a focus on regression. Here, regression shows the associations between the predictor variable and outcome. So HR is positively and significantly associated with white blood cell count, and so is the drug administration, and drug administration is also positively and significantly associated with heart rate. The variance section represents the residual error. Residual error is the measure of how well aligned fits an individual data point. So residual error is the difference between those two things. And because the other residual error is not too high, so if you can see the heart rate variances, this estimate number is very high. So that shows that there is large residual error. However, this did not stop our analysis of the model, because residual error doesn't necessarily mean that something is wrong with mediational analysis, but it likely means that there is some unexplained difference that can be investigated later. And the white blood cell count residual error was not too high. So R-square values shown indicate that collectively heart rate and drug taken account for 20.4% of white blood cell count change. And we could have predicted with our high residual error, drug taken only accounts for about 2.7% of heart rate change. The direct effect, indirect effect, and total effects found are defined in the parameters estimate summary. So the direct effect was 0.076, the indirect effect was 0.079, and the total effect was 0.154. So this proved that mediation paths A, B, and C were significant in impact of drug taken on white blood cell count and mediation. This is a visual representation of what we just saw in path analysis. So using SemPlot, this conveys Levon mediation model summary results of standardized parameter estimate as weighted edge labels. So you can see that here. And this is another visual model that represents path analysis using the graph-sem function, which is through TidyR. And this conveys the mediation model summary results of regression estimate as path values and variance estimates as residual error. So this is my discussion section. So because this isn't an experimental analysis, the residual error can give us more information about future study. Examining sources of residual error could indicate heart rate as a possible mediator between another X variable and white blood cell count that could be determined by modeling that would be useful in the broader study. Additionally, an extension of this study would feature path analysis examining 5 additional mediation models with differences in absolute differential lymphocytes, monocytes, basophils, and eosinophils, neutrophils as Y variables. This study's mediational model, along with those 5 additional models mentioned, could influence the interpretation of the results of the broader study as an experimental check of the effects of propranolol on outcomes in various cell type counts and heart rate, which may influence DNA damage as a secondary effect, like discussed initially. So this is my acknowledgements section. Many thanks to funding from the National Cancer Institute that allowed for this project to happen with my mentor, and a big thanks to study participants because that is how we got our data for this project. I'd also like to thank Dr. B, Jessica, and Amelia for making this experience at Hillman so great for me. I think that I learned a lot that I can take into further studies of STEM. And I really got to see an intersection between computer science and medicine, which was very helpful. So I would also like to thank Academy leaders, including Dr. Boone and Solomon Lipschitz, for all of their commitment to this program. And that is the end of my screen sharing.
Thank you very much, Maria. And I'll clap, and others can clap. Are there any questions? Once again, I want to start off. I ask if there are questions, and then I interrupt. So the software that you're using, this method, is this something that that you found on your own, that you brought into this project?
Yes, this is something I was investigating mediation packages over the summer because this was kind of the direction that we were going in for like my project with Hillman. And I am somewhat familiar with R, but not in like a medical research scientific sense, I guess. So I had to do a lot of research on what packages were helpful, and I did find other mediation packages, but what made path analysis very helpful is that it was a single directional model. So that really helped us to interpret the data a lot better. And Levon seemed to be the best fit based on all of like the community groups with the R software. So.
Okay, very nice. That's impressive. And then if I understood the results, what you were showing is that the drug has mostly an influence on heart rate and also a secondary influence on the white blood cell count, and the heart rate also has an influence on the blood cell count. But the largest influence that you saw was between the drug and the heart rate. Is that correct?
The largest influence that I actually saw was between heart rate and white blood cell count. But like I said, it depends on the paths that we examine. So essentially, drug does have an influence on heart rate, and heart rate does have an influence on white blood cell count. So that does increase the total effect that is calculated by adding the C path drug to white blood cell count. If you add that to the A and B paths, which are drug to heart rate and heart rate to white blood cell count. So overall, the total effect is mostly seen. The biggest total effect is seen in all of the paths taken, but the secondary one that is the largest is between heart rate and white blood cell count.
Okay, thank you. It's a very nice project. Are there additional questions? All right, good. Then we can move on to our next speaker, who is Sean Russell. I've been looking at SpongeBob for this entire session, so I'm really eager to hear what SpongeBob has to say.
I'm Christine Leeper, and I have the great honor of introducing Mr. Sean Russell, who I've had the pleasure of getting to know and working with this summer. And anyone who's already lucky enough to know Sean is aware of how inquisitive, intentional, and hardworking he is. And this work that he's going to present today is largely his own, from the background research to the design of the study, the analysis and the interpretation. He really took full advantage of this clinical research opportunity. And so I'm proud and excited for him to share this important pediatric trauma injury prevention work with you today. So take it away, Sean.
Okay, I will share my screen. Okay, so thank you for the introduction, Dr. Leeper. And as stated, I'm Sean Russell. And the study that I did was a bike helmet study. And this fell in the realm of a clinical project. And that sums up the introduction to this. So in order to be a part of the study and be able to actually be qualified for this, I had to complete courses in the city modules other than the ones that Hillman already had assigned. And basically, the short description of completing these certifications and earning them was just so I had the qualifications to be a part of the team. And so, yeah, just basically so I had the qualifications and I earned the training. It did take a while, but I wasn't actually like running up mountains or anything, but it did take a while. So to the bike helmets itself and the study, I read manuscripts that involved biking or bike helmet related topics. And in doing this, I already had like my opinions on biking and whatnot. And I'm sure we all know about bicycles and kind of already have an idea of the bike helmet usage. But I read these manuscripts to sort of give validation to what I'd already thought. So what I learned was that, of course, bike helmets are important to prevent head injury during bike accidents, but many adults and children don't consistently wear helmets. In the pediatric world of things, and in general, it is important to understand who to target to increase the number of helmet wearers, as whenever there's like bike crashes and the head injury, the impact could be lessened if bike helmets were worn. So following in suit with this, UPMC holds injury prevention events. I mean, they did hold these between May and June throughout places in Allegheny County. During these events, they were basically giving out safety prevention actions, but one of the things they were doing was giving out free bicycle helmet education and distribution. This was important because this could also be a place where we could conduct a study. And in the next slide, I will go into more detail on how we actually did that. So at two of the UPMC injury prevention events at West Mifflin and South Fayette, Dr. Stephan, he collected data via a survey that was administered to parents on a Google forum. And basically, this survey set out to answer questions pertaining to the gender of the parent and child, race of the child, age of the child, and the percent of time children wore their helmets and percent of time parents wore their helmets. The key factors in the first few questions were just getting the demographic of the participants, and the second two questions would help to formulate a hypothesis, which were the key point of running this study in general. So the hypothesis was that children would wear helmets more often if their parents/guardians did. And this was just hypothesized just based on an assumption, and the data that we'd run would be able to certify if it was validated or not. So the methodology that we used was we summarized the data using summary statistics, and to do this, we use Stata, Social Sciences Calculator, and SPSS. I personally use Social Sciences Calculator, and that's where I actually did the summary statistics, and I found the counts, percentages, and the median. Again, this was just, this was just more so to go in a deeper level of the demographics and sort of like find like the median age of the children and whatnot. And to actually see how close the hypothesis was, or to measure the hypothesis, I mean, to see if it was, how accurate it was, we used Spearman's row calculator to assess for the correlation between child helmet use and adult helmet use. A Spearman's row calculator, it just, as it kind of implies with the correlation part, it kind of, it performs a calculation to find the correlation between the variables that you enter, which was key in finding the correlation in the hypothesis. So the first thing to go over is the summary stats. Just to note, there were 145 total responses, but due to 26 stating that they didn't ride bikes, they were excluded. This was because they didn't fall in line in the 0% wearing category because they didn't wear helmets, and they couldn't fall in line in 100% because they didn't wear helmets because they didn't ride bikes. So there were 119 people in the final analysis. And the data was pretty even between South Fayette and West Mifflin at 45% and 55%. And to start with the child age, you can see that the median is on the outside, and then the IQR is in the parentheses. Median and the IQR were used because they were better. They were better than using the mean in this realm because they were more accurate in getting this data in this range. So the gender was also pretty even at 44% male and 56% female. The races were pretty predominantly white at 79% and 10% Asian with one race and 1% Black. Now, for the part that would be measured with hypothesis, the child helmet use percentage, the average child wore their helmet 100% of the time, and the average adult wore their helmet 50% of the time. And the bottom part just is the footnote that I explained in the second part. But to explain the Spearman's row calculation that was performed, with this first part, this is the graph. This is more so a scatter plot. And basically, the fitted values are right here. And then the graph of the child helmet use percentage is the circles. So in understanding the graph, it's hard to understand if there's a correlation between it. So basically, if it was like perfectly diagonal, it would mean that there was like, I guess, a perfect correlation. But the fact that it is not perfectly diagonal just means there is a correlation, but it isn't as strong as, of course, a perfectly diagonal. But to explain the equation that kind of validates this and everything, the Spearman's row. So in general, with the Spearman's row, the row being closer to 1 indicates a very strong correlation. And the fact that it is 0.58 indicates that it is a moderately strong correlation. With the P right here, this is the probability. In general, whenever the probability is in that 0.05 or less range, it indicates that it is a strong correlation between the hypothesis being correct. And the fact that P is less than 0.001 indicates a very strong correlation in the data. So in general, just to explain all this, there is a positive linear association between when a child wears their helmet and when their guardian wears their helmet. That basically just sums up everything on these slides. So the limitations to the data was that it was based off of parents' interpretation. it may have been skewed in some manner in that likes. And the fact was the study size wasn't very large at 119. It could have definitely benefited by being larger. And there also may have been a bias in the population due to mainly helmet users showing up. So to say this in a different way, people that don't tend to wear helmets may have simply just not came to the event as they didn't wear helmets. So yeah, but the conclusion that the study still did find key information in that there is a positive correlation between a parent or guardian wears a helmet and when their child does. Due to this, parents are an ideal target audience when promoting helmet use, and this could go on to help the target audience in terms of, since parents are, this could help increase helmet usage by targeting parents more often. Now, like I was saying, with the limitations, by repeating this study in a larger population, we'll be able to validate this even more and possibly find other data to analyze and other correlations. The next steps would be to co-author and submit a manuscript based on this study to an injury prevention journal. I think that would be pretty good because this study did come up with some key points, and again, it would help to reduce, it would help to increase people wearing bike helmets, which would end up reducing head injuries from bike accidents. So I do think that would be pretty good to do. But in general, that is everything for me. I just would like to thank the team behind like the study and all that, which was Dr. Leeper, Dr. Stefan, and Dr. Zach. Also, thank you to Hillman Academy and their YES program and the UPMC Department of Surgery. My pet dog, he put this picture of himself on the slide, so I also wanted to give a shout out to him. He also wanted to be a scientist, but since he's a dog, he can't be a scientist. But that's everything. So thank you, and I'll stop sharing.
Thank you very much, Sean. And I'll clap again. That's an interesting project. I noticed that one of the data points that you showed had a parent who wore the helmet 100% of the time and the child only wore it half the time. And I was just wondering if this is, the parent is thinking, oh yeah, well, the kid always wears the helmet with me, but not with the other parent or something like that. It's interesting, you pointed out that there are good reasons that there might be some issues with the data because everything is subject to the parent's interpretation. Are there any questions from the audience? None? So how has this study influenced, Sean, your aspirations for the future?
Well, it gave me experience in doing research and like reading manuscripts and all that. And I think it influenced me more so in understanding that I'm capable of doing work like this. So I think in terms of building confidence, it definitely served as a confidence builder. And so could I see myself doing this work? I could see myself doing this work. But yeah, I definitely think it served key in building confidence that I could do this work effectively.
That's good. And you learned a lot from the city modules, of course.
Yeah, I learned a lot. It was great.
Very good. And can I ask one other thing? Do you wear a helmet when you ride a bike?
Can you say that again?
Do you wear a helmet when you ride a bike?
Oh, I'm part of a biking program, Pittsburgh Youth Leadership. So I always wear a helmet whenever I'm riding a bike. So
excellent.
I do. Yep.
Great. An advocate for helmets. Are there additional questions? No. Okay. So on our schedule right now, we have Anshul Shah, who is not on the call. And then after Anshul, we have Marley Saul, who is also not on the call, it seems. So it appears that we are finished about a half hour early. So, unless somebody pops up and surprises us, what I'll say is we can end the session now. And I, this was a great session. I think that we have a lot of good research from our scholars this year. It's always better if things are in person and if they can get on the campus and really mix in with all of the researchers. But still, I think that they've done an excellent job, considering the circumstances, and have really adapted well to this remote type of environment. So thank you again. Very well done to all the scholars. There's now just a long break until 2 p.m. I asked all of the scholars to go to the closing ceremony. I posted the Zoom link in the chat. Scholars and mentors as well. You're welcome. And that's just a ceremony academy-wide. Anybody who wants to view that can view it on YouTube. I also posted that link in the chat. And I want to give another round of applause to all of our speakers for a job well done. So thank you very much. And that ends this session. So thank you.
Thanks, Tim.